Hey guys, and welcome to another fun Applications of Quadratics. Okay, so what we're going to be doing today is we are going to be kind of circling full circle back to what we did in the beginning of the unit, but now we're going to use algebra to answer these questions. Apologies, they are word problems, so put on your thinking caps, and here we go. All right. Oh gosh, a baking soda rocket. What? It's a mouthful. Let me try again. A baking soda rocket is fired upwards. I gotta get my highlighter here. This is cray-cray. With an initial speed of 80 feet per second. The height above the ground can be modeled using this equation. Okay, so it's giving me like a lot of information. What's most important is that I know the height is h and t stands for time. Okay, so the path of this rocket is modeled by a quadratic. That makes sense to me. If you guys have ever made a little baking soda rocket, have you? I don't know if I have, but maybe I have. Oh, it's going to go up off the ground, right? It's going to fly, rocket, and then it's going to come back down. Are you with me? So at what time does the rocket hit the ground again? Okay, so clearly it's starting on the ground at 0, and what we have to figure out is when it's going to hit it again. So what I did was I took the liberty of graphing this function for us. So you're welcome, just so we can see what it looks like before we start. So here he is. I graphed negative 16x squared plus 80x. The issue here is, okay, I know he should be a quadratic. It makes sense why I'm not seeing the vertex because this is my height. And the rocket isn't just going to go to 6.67 feet. I don't know. Maybe it'll go up to 20. Let's see. Oh my gosh. This baking soda rocket really is going pretty high. Oh my gosh. Higher than 50 feet. I don't know what baking soda rocket's going to reach 100 feet in height, but here it is anyway. Okay, so this is the path of the rocket. The rocket's going up, 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 up. It's going to hit its highest peak, and then it's going to go and fall down, okay? And it's going to reach right here, its x-intercept. So we already have the answer. When is it going to hit the ground? It's going to hit the ground when x is 5, okay? Or at time 5 seconds. But what we have to do is actually answer the question. We can't answer it graphically. We have to answer it algebraically, which means we need to show some form of work. The hardest part about this question is knowing that they wanted me to take the path of the rocket and set this path equal to 0, because I want to know when is the height equal to 0. And so that's kind of what I just did here. I set up my height and I set it equal to 0. So now we have to solve this. Since it says algebraically, we can either solve this by factoring, complete the square, any of those guys. When I look at this, immediately I am going to think about factoring, okay? Because negative 16t squared and 80t, they have a GCF. Whoa, that was weird. The thing that they have in common, they're both multiples of 16, and look, each term also has a t. So I'm going to factor out a negative 16t. And I'm going to put what's left in parentheses. Negative 16t times t will give me that negative 16t squared. I'm factoring out a GCF. 80t times negative 5 will give me, negative 16t times negative 5 will give me that negative 80t. All right. Oops, I thought all right, I'm just going to keep scribbling over and over again and nothing's going to happen. Sometimes if I scribble, it'll erase it, but it didn't this time. All right, so last but not least, when you're showing your work algebraically, once you have it factored, you have to set each of those factored pieces equal to 0. So 0 divided by negative 16, oh yeah, that's 0. So at 0 seconds, it's going to hit the ground. Okay, no surprise because it's starting on the ground. And also when I add 5 to both sides, it'll hit the ground again at 5 seconds. So the trickiest part, guys, I think about this question is kind of knowing that you had to set it equal to 0. That's it. All right, let's move on. This one is a bit more in depth. But what's exciting is that we get to draw flowers. So I hope you have some colored pens, some crayons, some pencils. I don't know. I'm going to pick a nice color. Maybe I'm not going to pick any color. Oh, here we go. Purple. Okay. A landscaper is creating a rectangular flower bed. For which to grow some chrysanthemums and violets. I put violets in here because I'm using a purple pen. Okay, maybe I'm going to put a rabbit in here. A little rabbit. Okay, guys, this is, I don't even know. Wait, the rabbit ears go up like that. Okay, this is terrible. Don't look at my rabbit. Okay, I tried my best. All right, so the width is half of the length. The width is half of the length. Oh, man. Okay, so I have a couple options. If I want to call the length L, my width, which is over here, is half of that length. The width is half of the length. So you could write it like that. One of my thoughts that I have, and I like this better because it allows me to avoid fractions, might be something you might like, is since the width is half of the length, if I say that the length is 2x, the width is half of that. So what's the width? X. And I think that's a lot nicer because it helps us avoid fractions. Okay. The area of the flower bed is 34 square feet. All right, guys, you better know that the area of a rectangle is length times width, or if they give you base and height, same thing. Okay. So I know the area is equal to 34 square feet. Length times width is 34. All right. 2x times x is 2x squared equals 34. Now we just got to solve this guy. Because it's something squared equals a number, it's kind of easy. You can just divide both sides by 2. And 34 divided by 2 is 17, right? And then last but not least, square root both sides. So I've got x is equal to the plus or minus the square root of 17. I'm not going to pick the minus, and the reason I'm not going to pick the minus is because you can't have a negative length. So I've got my answer, right? Wrong. It says nearest tenth of a foot, and I did not do that. All right, so that means I have to hop on my calculator and tell my calculator, hey, calculator, what is the square root of 17? Oops, why didn't it go on the inside of that guy? 17. 4.12. So because it said nearest tenth, that's one decimal place. So the length is approximately equal to 4.1 feet. Okay, when you round, you use those little swirly equal to symbols. It's fun. All right, guys, one more. This wasn't that bad. I thought this was going to be way scarier. I think it's because I did such a good job drawing a rabbit. If you can do oh, look at this rabbit is much nicer. Oh, look at his little bunny tail. All right, should we move on? All right. Oh, look, he has little hands. Okay, next page. Here we go. Oh, John and Sarah are trying to save money for a car. Oh, God bless us all. Here we go. John is saving money with this function, 60 plus 5x. Sarah will save money through this function, x squared plus 46. I don't know why they're modeling their money by functions, but who knows? After how many weeks will they have the same amount of money? So essentially what we need to figure out is when will Sarah and John's money be equal, right? We should probably say, oh yeah, we know weeks is x. So Sarah's money is x squared plus 46. And I want to know when that is equal to John's money. I'm looking for where these overlap. Now, what's interesting is, did they demand that we use algebra? Did they say to solve this algebraically? No, they didn't. So how can I solve this guy? Oh, if you said graphically, you know what's up. Let's go in and see what we can do. All right. So we have to graph the two functions here. Ooh, you know what I can do? Watch this. I know Miss Ruscio and Mrs. Hayes do this all the time. I'm just not as fancy as them. Oh, yay. All right. So new document. If you have your own calculator, follow along with me. Don't make me do all the work. And so I'm going to graph Sarah's function, x squared plus 46. And notice how it's not showing up. And that's because my calculator's broken. Just kidding. This is a parabola that was shifted up 46 units high, and this is only going up to 7. So I'm going to go up to, I don't know, I'll go up to 80. I bet I'll see that. Oh, there she is. There's my parabola. So here's Sarah's function written in blue. Now I'm going to graph John. His is linear, and his is 60 plus 5x. Okay, so I've got John in red and Sarah's function in blue, and I need to see where they're going to be equal after how many weeks. Now, I can clearly tell they're going to intersect, but I can't see it, so I need to get higher. So let me change that 80. I don't know. I'll do 120. Let's see. Oh, that was a good amount, because now I can see when John and Sarah's are equal. So using your calculator, the calculator can actually tell you the intersection point. The way we do that is, and I would write these key presses down if I were you, menu, analyze graph, intersection. It's going to tell you to do the lower bound of your intersection point, just means go to the left and click. And then you want your upper bound, you're going to go to the right and click. So the intersection point is 795. That's the intersection point. But you have to answer how many weeks. So that is your X value. So after 7 weeks, they will have the same amount of money. Do you know how much money they will have? Yes, 95 is the amount of money they will have. Now, I did not explain how I arrived at my answer. Hold on, I can't do two things at once. After 7 weeks, they will each have $95. Okay. So you have to really explain what you did. So if you think about what we did, we graphed Sarah's function, we graphed John's function, and we looked for the intersection point. The reason we picked the only intersection point in the positive is because you can't travel back in time. We can't go backwards. And since the x-axis represents time, we only care about that positive. You need to write out an explanation, okay, because it says explain. And I know that's annoying because it's a lot faster to type it than have to handwrite it, but that's what needs to be done. All right. I hope you guys had a fun time with me, and I will see you, I don't know, if I see you. Take care.